Hey, and welcome back to Class 8 and the second part of our plugin series. So this week we continue where we stopped last week with the command data plugin and how to create its interface through the source code. So we're jumping right back in exactly where we stopped last week. So for now we are continuing with the layout. We have our first text, our first numeric field, creating the second one with the same numeric field. And you may have noticed that while I left this ID at 0, because we're not going to access it, I passed in a variable name here instead of a number for the ID of these number fields, because obviously these numeric fields I want to access later on. And what I'm always doing, and I think that's the best way to do it, I mean, technically you could just put in a number here, just like I did with the group. But what I'm doing is I'm usually defining global variables up here outside of any class definition. I'm usually beginning them with UI or some similar lettering in the beginning, so I know these are just constants that I use for my UI elements. And then I pass in a number. And your numbers should begin at 10,000 and then going upwards from there. And because that's a safe range. And yeah, then I'm just numbering them by adding one on top of each other. And by using this way, this is much less confusing than using numbers, because later on when I want to, like, let's say, access my offset X or Y, I don't want to have to remember that 5 was X and 6 was Y. It's much easier to remember just, I use X and Y for that. And internally it will be using this number, but for us it's much more human readable to use these constants. So that's why I'm using those here. And also always remember that if you want to set these flags, these are just like my constants here. These are just standing for a number, and they're part of the c4d module. So always have to remember that you have to prepend these with the c4d dot in the beginning. Right, so anyway, we have created these elements now, and we gave those a default width of 50 pixels and a default height of 15 pixels. And we end our group, and that's giving us this row of elements. Following that is the row of elements for our vector, and unfortunately there's no vector field as such here, but I'm just using 3 numeric fields, and that's working just as well. And this again is a group of 4 columns, because I have one text for the description in the beginning and then 3 numeric fields. And then I'm adding a button at the end. So that's here. And the button again expects an ID and some layout fields, a default width, a default height, and a name. So while these here get no labels and I have to put a static text in front, the button just uses this name here and fills out the button with that text. Alright, so that's the bottom part of the UI, and you notice I have skipped the one at the top, and that's because this is a slightly more complicated than the rest. The static text, of course, is not so complicated, but the custom GUI command, that's a bit more complicated. Because what we wanted here were 2 fields where I can drag and drop objects in. Now these are link fields. You may remember them from when you create user data objects or user data tabs. You can add user data link fields where you can drag and drop objects in. These are the same. Unfortunately, there is no command in here in the GE dialog to add link fields. So what you need to do is you have to create a so-called custom UI field. These custom GUI fields, there are several types of them that don't have their own create functions within the GE dialog, but nonetheless that are part of the available UI elements within Cinema. And if you look at the documentation in the C++ documentation, that's the easiest. You just click on the index and search for custom GUI, and that will give you a number of types here that you will probably remember and notice from when you create user data elements within previous classes. like the cycle button, file name, and there should be there's a link box. So a long slider, that's for example, that's a long, and also I think there should be a real slider here as well. There it is. This is the combined numeric and slider fields. So these kind of fields, there is no add function for those in the GUI dialog itself. For those, you need to use this add custom GUI function. And we did that now for the link box. So we create again the ID. We pass in the custom type. So that's part of this. So if we have the ID, we have the custom type. That's called plugin ID here, but it's the custom type that we want. We can pass in a name. Some fields use it, some don't. The link box actually doesn't. So if you want to use a link box, you still have to put a label in front. We can again use the layout flags here and minimum height and width. And then you can, or have to in some cases, pass in a base container to contain the settings for that field. And we're doing that as well by creating a base container, a blank one in the beginning here, and then passing it on at the end of that function. We're not actually using that for anything, it just requires it to be created. So we're creating our link box here, and then after it's been created, this is returning an ID, and that ID we store in a parameter called, or in a variable called link source. And that's going to be our source object link. So while these other elements we can access directly and get their numeric values, for example, these link boxes, they have to be accessed through the return value that's coming from the add custom GUI. So we have to access it through the variable here, not through the ID here. So that's something you have to keep in mind. And we're doing this twice again for the target. So we have two links and two variables that we will later use to access whatever is in the link box. And that is how you create a user interface through source code. You can add much more here, of course, and there are more types that you can use. You have seen all the custom types you can play around with, but for now this should be enough. And what we also do is we set some default values here, and that's going to show you how to access these parameters here, again by using these constants that I've set. So what you do is you use these functions set long, set real, and there's an equivalent get long and get real, and get other types as well. Let's see, where are they? Here we go, the get and set methods. So you have all kinds of different types here. You have the long and real, you have the string for text fields, you have vector, and so on. And yeah, you use those to preset your fields with data, and also to get the data that the user entered into those fields out of it. And these set methods, they are also being used not just for the obvious setting of the value in that field, but they're also being used to set the initial default parameters to the field, and the minimum, maximum, for example, and the step size, and what kind of format that numeric field is supposed to expect. And we're using that in our numeric fields to give a minimum and maximum of minus and plus 5,000 and a step of 0.1, and the format we tell it to expect real values. And we're doing the same for the other numeric fields that we have here. The where are they here? These two, the start and end ones. They are long, so that they expect integers, so full numbers. And yeah, we're pre-filling them with the min time and maximum of our document, which is basically this. So this one here, these two fields. And of course, if you remember, when you call these functions here, that returns not the frame, but a basetime object. And from that basetime, we get the frame and we pass in the FPS. So in the end, all of this, that returns the frame, which is 0 here and 90 here. And we're putting that 90 into the 2 and the 0 into the from field. And that's presetting our UI like this here. And with that, we return from this call. So this is being called automatically. We are when the dialog opens, you can see we are not calling that function. That's being done automatically by c4d. The dialog opens and the create layout is being called to display the layout. That's being done automatically. And this function you see also expects no parameters, so it's just getting a single one called self. And you probably noticed, and I haven't mentioned it yet, that all of these functions here begin with self in the front, and also we return a true in the end, even though we're not actually using it anywhere. So what's this all about? This is part of how classes and object-oriented programming works in Python. A method within a class always expects self as its first parameter, even if you don't want to do don't require any parameter at all, self always has to be the first parameter. So if I wanted to add another parameter here, whatever number, self still has to be in front. But when I call that function, if I were to call create layout with that parameter, I would just pass in that one here, because the self part is automatically being added in front of all other parameters. So I never have to pass in this self. It just has to be in the method definition. Now, what is self? Self is a pointer to the instance of the object that we have created. So, and this goes back into object-oriented programming. Maybe some small explanation what this is exactly. I mean, like I told you, a class is more or less a description of a template for an object. And when I create a new instance of that class, I create a new object based on that template. And obviously, not with this dialog, but with other classes, I could create numerous of those. Let's take, for example, the base object. When I create 10 cubes, I create 10 objects based on the cube class. But all of these, once they are created, are of course separate objects from each other. And I can change parameters on each one of them. So they're separate entities, all based on cube. But when I want to change something in them, I can't, in the definition of cube, I can't know which cube is going to be which. So when I create a function that is supposed to change, for example, the size of the cube, I can't tell in advance that cube number 10 will get size 500. What I can say is that the object that's being created based on my template, the one that is currently being calling that function, that is supposed to change its size. Unfortunately, this is quite tricky to explain at this point, and to explain it, I would have to go on several tangents, and I think that shouldn't be really part of this class. Just have a search on Google really for self, and also, like, first of all, if you're not familiar with object-oriented programming at all, have a look at that. And what you see there is probably a mention either of self in the Python context, or a mentioning of this. Other languages don't use self, they usually use this, and it's basically exactly the same. They always point to the current instance of that object. And, well, what it does in our case here, what it means is that when I call setTitle, I'm not just calling setTitle, I'm calling setTitle, the setTitle method of GE or of position cloner dialog. So from here we go there and back into GE dialog. So position cloner dialog inherited the setTitle method from GE dialog, and then we created an object, and that object inherited those methods, and we are calling the setTitle of that object. And using the self, we can also create a variable here, and normally when we create a variable, it's only being available within the methods that we called it in, or that we created it in. Or if we are creating it in a loop, for example in a for loop, it's only being available within that loop. Which is why in some cases like this up here, we created global variables, so they're always available to all. The difference being here when I call it with self is that when I create this variable here, that's not being created within the context of this method. It's being created as a class variable. So this exists not only within here, but it exists within here. So that means that not only within create layout I can then access this variable, but I can also access it within all other methods. However, I can't access it outside of this class. So these class methods are available anywhere within the object created based on position cloner dialog. So this is a lengthy explanation, but it's important to know because later on we of course we want to access this value here, and by creating it as a class variable we can access it anywhere in the future. Right, and that is our layout done, and when it's done we are returning true, and all the methods in a class expect to get some sort of return value, and if there's nothing to return, then what you do is you just return true. Or you can return false if there was an error, but usually you return true, and that's all. And that's finishing the layout. So now our layout is open, our window is open, and it's just sitting there. And what happens then is that then there usually is some sort of user interaction. And when there is user interaction, a command is being called. And when I click on something, that's being issuing a command, and automatically this method is being called within the class, and it's being passed, well, first of all, self again, and then it's being passed an ID and a message. And what's important for us is the ID, and this ID, that's the ID of the UI element that the command came from. And the message is then the message that this click sent. But what's more important for us is, first of all, we want to find out what that ID was, and in most cases this was a button. And of course we created a button here, so we check that ID and see was the ID that button, and if it was a button then we know somebody clicked it, and then we can kick off whatever else we want to do. And let me just show you what is happening. So I'm just editing the source code of the plugin, so that's still sitting in the plugin folder in my app data. And let me just print the ID and also print the message, save it, and this is where this button comes into play. So I can now reload it, and you see here this row came back, so it has reloaded it. Also notice that the UI disappeared. That's a side effect of reloading the plugin, so you have to close it and reopen it, and then you get the reloaded version. And now when I press on copy keys, of course we get an error right now because this is all still empty, but you also get this number here, and that was the ID, and you get a base container object, and that was the message. So you see here this 10002, and if we remember and we scroll back here, that's the number of our button. So that's basically how you control the flow within your plugin. You just define a number of UI elements that a user can click, and once he clicks it, this will issue a command with the ID. Now we get rid of this again, and then we check the ID, and if the ID is one of our elements that we want, to find, then we just, well, continue with whatever we want to do. And what we do is, of course, we wanted to copy data from one object to another, and this is basically what we already did last week. So I'm just going to point you to the changes that I made, because it's a bit different from what we did last week. The basics are still the same. We're getting the document, we're getting the frame rate. Now we're getting the source and target object from that link field, and you see here, because they were defined as class parameters, we can still access them even though we're in a different method, and we're using the function getLink, and that's getting the link from that link object, from that link field. And then we have our offset that we built from the numeric values in those numeric fields. And then this is new. We didn't do that in our previous scripts, but that's usually something you want to do, and this is undo. You may have noticed this, or maybe not, when you played around with the previous ones and you did undo, nothing happened. That's because you have to explicitly tell Cinema to start undoing. So this is where, so basically everything that happens after the start undo, up to the point where you call end undo, anything that's happening in between, that's what's being undone when you press Ctrl Z or Z. If you don't do this, then everything you make here is final. So we started the undo. We're getting the frame. Again, we're getting it from the UI element. And this, again, is a bit different from what we did earlier. So you remember previously we used the different syntax with the square brackets. Within here, we have to use this one now. We have to use self and get long. So instead of just using the square brackets and telling it to get it from UI frame from, you have to explicitly tell it to get a long value from that field or a real value from that field. And then we're storing it in here. This is exactly the same as last week. So we're just making sure that on the target object, we have our animation tracks. And this is a bit different because last week we were doing a live capturing basically of the animation of the other object. What we are doing here now is we are looping through every frame from the beginning to the end. And I'm adding one to the end frame because usually when we tell, like in Cinema, it depends. I mean, you can. This is personal choice, really. When either you can tell that when you say the end frame should be 90, that frame 90 should be included, and if you want to include it, then you have to add one on top, because when you define a range here, it will start at the start point, and it will end at the end point without the end point being included. So our end frame was 90, and this would loop from 0 to 89. And stop at 89, and if we want it to continue to 90, we have to add one on top. So that's the reason why I did that. If you want to decide that 90 should really not be included, then just leave end frame as it is without the +1. Then we just get the time based on that frame. So we're looping through this, and we're getting the base time here for that frame, from 0 to 90, and then I'm calling the copy command, and I'm copying at each frame, I'm copying the current value from that curve from the source to the target, passing on a couple of parameters to that new function here, which is a bit different to the other one before. First of all, I'm using a method here, but I'm basically creating a quick list of these three values, which are these global values here that I defined. And by doing that, I'm just saving myself from having to type this 3 times for every one of those, because this is just going to take desk and looping through these 3 here, and from now on desk will be first this one, then this one, then this one. And then I'm just getting the track from the source object and the curve from the source object and the one from the target one. Then this is also new. I'm going to the curve, because the thing is I could technically check the source curve for an animation key, and then if there wasn't key, I could copy the key. But I wanted to bake the animation, so on every key, on every frame, I want to have a key on the target object. So I can't be sure that on the source object there will be a key on every frame at that particular time. So instead, I'm getting the value on that curve. So if it's an animation curve and there's one key here and one key here and there's a curve in the middle, there won't be a single key, of course, in the middle. It's just one in the beginning and the end. But by using getValue, I can just get the specific value on that curve at that point in time, and I'm feeding that into a new key and I'm putting that into the target. So that's similar to what we did last week. And to show you that it actually works, we're going to take this function and we're going to create a second object. And first of all, there should be some animation, of course, in here. So let's just do some very fancy animation like this and like this. So, wow. And then we take the cube as our source and the sphere as our target, and we add some, don't know where we, let's use Z-axis, so put some stuff on top. Yeah, oh, we still have all that output in here. That's because I didn't reload. So let's just, did I save? Let's see, did I save this? No. Okay, I saved it now. And actually, I commented this out earlier, and that's why we got the error message, because we clicked it and the fields were still blank. So let's do this. So actually, if the source and target fields or the link fields are empty, nothing should happen. And oh, actually, there was one other thing. After we have finished, and that should probably be, yeah. After we have finished with the copying, I'm calling an event add. It's just so it refreshes the screen and stuff. So let's save this and reload our plugin and get rid of the output. And load this again. Cube as a source, sphere as a target. And let's do -500 here. Bam. And you see here, there's the keys. And if I play, there we have our animation. So it's working. So now that this is working nicely, I can show you a little advantage of creating your UI in this way. It's a bit tedious to type out all the details here, and using the description file that I'll show you later, it's a bit easier to build your UI, but it has the advantage that when you reload your plugin within Cinema, these changes, they will actually make it into the reloaded plugin. So if I just were to change this, if I were to change this to copy all keys, it's not a massive change, but at least there's something in here. Or if I, let's just add another few buttons in here. And if I reload this here now, open it, and there we have our change immediately available. If I were to use the description files, all the changes require for me to restart Cinema every single time. The reload won't take changes into the external files into account. So that's something to keep in mind. Let's undo that change again. And with that, we're happy with our plugin. And now that we're happy with it, let's reload it. And we're back to, where we were. And now we're happy with it, we can encrypt it now if we want to pass it on to other people and we don't want them to see what we did in there. So within script, there's the source protector. Click on it, it's very straightforward. You just go into your plugin, select the source code, the PYP one, open it, and that's all. So now we go back into that file. We have a second file in here called PYPE for encrypted. And if I open that in my editor, there you go. It's a binary file now. and well, people can't really do much with it. But it will still load as a regular plugin just like this one. It won't encrypt your resource files, so they are still open for anyone to read, but the actual source code, that's being encrypted that way. And that's that for this particular plugin. Now in the next step, we will create a different type of plugin using description files for the UI. Unfortunately, we've been running out of time a bit again this week, so the next plugins will have to wait until next week, but look forward to that because we're going to create both a tool data plugin and an object plugin. I'm looking forward to it, and yeah, see you next week. Bye.